Hi, I'm Wei Hong.
Hi, I'm Hunting, and
We
we
are
are
from
from
Team
Team
Fire
Fire
in
in.
Our Heart, with a burning passion for data science and environmental sustainability.
But we are not the only thing heating up.
Our cities are too, thanks to the growing threat of urban heat islands.
Urban heat island or UHI are areas within the cities that experience significantly higher temperatures than surrounding rural areas. This happens because buildings, roads, and other infrastructure absorb and retain the heat, while green space, which help cool things down, are often lacking in urban areas.
Let's take New York City as an example. In the summer, especially from late June to mid August, it gets seriously hot. We are not just talking about regular temperatures. On many days, the heat index, that's the feel like temperature when you include humidity, climbs past 90 degrees. And anyone who spent a summer here knows it can feel even hotter on the streets, especially in neighborhoods with more buildings and less green space.
Now think about how this heat affect our daily life. Take the Third Avenue Bridge in the Bronx. It's supposed to live to let the boats through. But during the extreme heat, the metal parts expand so much that it gets stuck. This did not used to happen, but in both 2023 and 2024, it got stuck during the summer heat wave. That's 2 years in a row. When the bridge cannot open, it causes major delay in the marine traffic. If you're a marine operator or part of an emergency crew waiting to pass, that could mean hours of delay or worse, critical service being blocked.
And it's not just about bridges or traffic. The human cost of extreme heat is heartbreaking. According to the 2024 NYC Heart-Related Mortality Report, over 580 people die prematurely every year in the city because of heat. That's not just a number. These are mostly low-income workers who have to be outside or older adults who can't afford air conditioning. And it's not random. The hottest neighborhoods are usually the ones with the least green space and the most vulnerable people. So UHI isn't just a climate problem. There are public health, transportation, and equity issue. This issue demanded more than awareness. It demanded intervention, and that's where our solution comes in.
Our approach integrates ground-based air temperature data with remote sensing input from Sentinel-2, Landsat-X imagery, and building footprint data. But instead of using everything, we meticulously selected a minimal set of key features, including the rise indices like NDVI, NDVI, NDWI, and MNDWI that effectively capture vegetations, urbanizations, and water presence. The result, extra tree regressor model that's simple, stable, and feature transparent, yet still deliver the world-class performance with an R-square score of 98.34%.
Before our model, UHI data was often static or scattered. Planners have to piece things together manually. That's why we designed a twin-track deployment strategy to make UHI management more actionable. First, we institutionalized urban heat hotspot detection as a living, continuously updated geospatial layer. This high-resolution heat map is integrated directly into NYC's Geographic Information Gateway. Urban planners can now overlay with other critical data sets like tree canopy and vulnerable populations to make smarter, more targeted decisions on where to invest in cooling infrastructure.
But we don't stop at that. Our second track is an interactive sandbox simulation tool. It allows users to test interventions such as planting trees and instantly visualize their predicted cooling effect. Agencies can even run the cost benefit analysis or equity assessments, helping them to prioritize solutions that are not only effective but also fair and efficient. By integrating with programs like Cool Neighborhood NYC and Plan NYC, this system become more than a model. It become part of how the city fight the heats, protect its people, and plan for a cooler future.
Most importantly, this isn't a one-off product. It's built with a feedback loop that continuously incorporates new field data and user input, allowing the model to evolve through regular retraining cycles. That way, it stays accurate, relevant, and trusted, evolving iteratively, just like how we approach the data challenge itself.
Although we start with no prior context experience, we were driven by a patience to contribute to the environment. Throughout the challenge, we keep learning, growing, and improving our model. And step by step, we arrive at where we are today.
Yes, the outcome we've achieved was far beyond what we imagined when we first joined. Our biggest takeaway is don't let self doubt stop you at the beginning, because with a sincere heart and commitment, anyone can make a difference. It's not just a data challenge, it's a mindset shift from being passive observers to active change makers.
So even if it is just a small step, start today. Together, let's build a better and cooler living world.
Thank
Thank
you.
you.